Hello, my name is David Wise. I'm a content developer at ICEV. Thank you for joining me for the Building a STEM Classroom Tools and Tech for Various Budgets. And I hope that you stick around for the live Q&A at the conclusion of this presentation. Now, a little bit about my background. I have a degree in mechanical and ocean engineering. So I focused on underwater robotics and electric vehicles. I've also been working on developing hands-on science and engineering projects for K through 12 curriculum for about the past 10 years. So overall, the goal of today's session is to give you some ideas about what it takes to make a makerspace or to outfit a STEM classroom within different budgetary constraints. We're going to be looking at what are the right tools and tech to maximize value for your students' projects, as well as some sample ideas of what you can start to accomplish once you've built a makerspace or a classroom like this. Overall, I cannot stress enough that a bigger budget doesn't necessarily make a better STEM classroom. Tools should only increase the efficiency at which your students can complete their projects or expand the capabilities of what they can do. So before we get into exactly what kind of things you should be buying, we're going to go over a few ground rules. So with these cost estimates, we're only looking at the initial upfront setup costs. So we're not looking at consumables or anything like that, or maintenance. That can vary depending on machines and on how well you take care of stuff. So we can't really factor that into our estimates. I'm also not going to include the costs of Chromebooks or computers, assuming a lot of schools will already have access for their students to those types of equipment. I'm also going to leave out classroom safety PPE just because it can vary depending on your district's policy or things like that. So those are some things you'll have to keep in mind when you're outfitting a classroom if you know that you don't already have access to PPE or computers. So right off the bat, our first low budget option for building a maker classroom is just some basic craft tools. In this case, we've split up our recommendations between items that each student or each lab group needs, as well as some items that are shared for the whole classroom. So for student items, we're going to be having a hot glue gun and glue. You need some sort of heavier duty cutters. So in this case, snips or a hobby hacksaw. A utility knife, which, while there are some safety concerns, a lot of those can be alleviated by cut resistant gloves, but we'll leave that at your discretion. You probably can work around it if you don't feel your students are comfortable enough or competent enough to use them. And then also we can't stress enough, especially in the case of hot glue gun and glue sticks, silicone mats are an invaluable tool for making classroom cleanup a breeze. And then also each lab group should have scissors, even though your classroom probably already has that. In addition to those tools for each lab group, you'll also want to have a basic mechanics or homeowner tool set that is shared for the whole classroom. Something along the lines of a couple of screwdrivers, some wrenches, maybe a tape measure. They'll vary a lot. You can find them on sale. You'll also want to have some needle files or sandpaper. So these are ways to fine tune fits. So especially with things like an axle or a pin connection. We'd also recommend getting a cordless drill and a charger. However, you'll want to check out how these cordless tool packages are structured, because if you plan on investing further down the road, it might save you money to spend a little bit more upfront and get a larger combo kit. That includes a cordless drill, an impact driver, a circular saw, and a handful of batteries. And then along with that drill, you'll also need a set of drill bits and a set of driver bits. So some sample projects that you can do with the craft tools is we've got a couple design challenges, such as a robot arms, mousetrap cars, popsicle catapults, or hydraulic crusher. Another good project with craft tools is BristleBots. And one thing to think about with BristleBots, so that's a small robot you can see in the upper right corner of the slide that's powered by a vibrating motor. So a motor with an offset weight that's balanced on, in this case, a nail brush. So this is a really good example of where you don't need electronic tools to do an electronics project. You can make do with just craft tools. In this case, you can get motors and batteries with wires already attached. You can just use wire nuts to connect them and you're in business. Besides the ICEV design challenges, there's also a handful of other engineering challenges that pair very well with craft tools. There's the egg drop, there's classic bridge and tower building competitions where your students either need to build the tallest tower or the strongest bridge based on a set of materials you give them. There's marble tracks or great ball contraptions, where those are various mechanisms and machines that will pass a ball, like a ping pong ball or a marble, between them. You know, they're commonly made out of Lego, but you can very easily make different ones, like marble runs out of popsicle sticks or things like that. Rube Goldberg devices, so that's where you have a seemingly simple task like buttering a piece of toast, but you have multiple steps and students have to design each step to accomplish that. Or, as I said, my background's in ocean and mechanical engineering, so I'm always like to do boat or raft buoyancy challenges where they need to fabricate a boat that can hold a certain amount of weight or withstand a certain amount of waves in a tank. And what is another great thing with using craft tools, if you're on a low budget, is these kind of activities pair really well with recycled or inexpensive materials, so it can make it even more budget friendly. Our next low budget option is breadboards and circuits. So in this case, each student group will need a solderless breadboard and the jumper wires, tweezers, a combination wire cutter wire stripping tool, switches, and then terminal blocks to connect wires to their breadboards, as well as a DC power supply. So for those of you that don't know, a breadboard is a way for you to prototype electric circuits without soldering. So it's a small piece of plastic with metal strips on the inside, and you can plug components in or out to make different circuits. And then the reason we suggest a DC power supply is it will prevent you from burning through disposable batteries, where your students can just use a USB power supply or other sort of like wall wart power supply to have their circuits work. In addition to that, for each lab group, for the whole classroom, you'll want to have some electronic component kits. So in this case, it's a good option to where you can incrementally invest by starting with a simple resistor kit or an LED kit, and then moving on to getting capacitors, integrated circuits, semiconductors, things like that. You'll also want to have 2 to 3 digital multimeters to help your students troubleshoot their circuits. And then we can't stress that enough in this case, that you'll really want some small part storage. Also, precision screwdrivers are always handy because a lot of these projects will have small screws of below the size that a typical homeowner's toolkit will work for. So you'll need them to loosen or tighten things like screw terminals. And while this might look like a lot of gear, it is really nice because electronic components are typically very inexpensive and they're sold in bulk. So each of these components are only a couple of cents for LEDs, resistors, capacitors, things like that. And it also can give your students some pretty invaluable experience when it comes to electric circuit prototyping, because they'll be using the exact same tools that they would in industry or in higher education, anything that like an actual electrical engineer would use. So some sample projects to do with your new breadboard and circuit kits. We have a specific design challenge focused on circuits, just on resistors in series and in parallel, capacitors in series and in parallel, and LEDs. You're going to have a lot of LED-based circuits because breadboards are stationary to the table. So dark or light detecting circuits, Knight Rider lights, so those LEDs that chase each other, reminiscent of the 80s TV show, as well as a laser light heart. So that's using light sensitive resistors to turn on or off sound based on if you break a beam. So the one other bummer about breadboards is they aren't the most robust when it comes to vibration or motion. So most of the projects your students will do are going to be fixed to the desk. So you can make things like a flashing bike light, but it probably won't actually survive being attached to a bike in a solderless breadboard. So speaking of a bike light, one of the simplest IC chips that you'll end up using is called a 555 timer. So an IC chip is a tiny package where it's a very commonly used circuit to make it easier to prototype. So in this case, this little chip can be used to output a square wave. And you can control the square wave's frequency and duty cycle by what resistors and capacitors you attach to it. So in this case, your students can make things like a kitchen timer using the one-shot mode on it, or a theremin where it varies the frequency sent to a speaker based on how close you are. So it can almost be an instrument. So now that we're getting to the first of our medium budget options, we'll look at a generalist fabrication shop. So these are going to be geared towards larger projects. So the items are shared for the whole classroom. We've got a drill press and a bandsaw. So that lets you drill holes as well as cut material in straight lines and in curved lines. You'll have a cordless drill and an impact driver combo kit. So remember how we mentioned that these usually you can save money by buying them as a combo kit. So this will actually not be that much more expensive than just buying a cordless drill. To continue material removal, we'll also have a power sander and a file set, so your students can fine tune anything they might not have cut as closely as they would have liked with the bandsaw. We also got a rotary tool or a Dremel. The non-Dremel brands are usually considerably less expensive, but might wear out a lot quicker. We also have the basic homeowner's tool set that we talked about earlier, PVC cutters, clamps, because you'll need to clamp things down when you're using the drill press, and then a hot glue gun and a soldering station. And if you're doing well on your budget and you still have room for a bit more, we suggest getting a jigsaw and a shop vac to make cleanup a little easier and to make it faster and more efficient for students to make curved cuts and cuts on things that wouldn't fit in the bandsaw. So some example projects that you can do with this basic fabrication shop is one of my all-time favorite projects, underwater robots or ROVs. So these are based on an MIT Sea Perch or MIT Sea Grant project called Sea Perch. And these simple robots are an absolute blast. They're built mainly out of PVC. It gives kids a ton of experience with hydrostatic stability and hydrodynamics and buoyancy and really simple circuits, as there's no programming to make these work. You're turning on and off switches to turn the motors on and off. So it's a really good example of a simple electromechanical system that most classrooms with a basic fab shop can build. And then you can take it a step further and allow students to customize their design, working with wood, plastic, other non-ferrous metals to really, get whatever ROV they think would be best for a task you might come up with. In the case of the photo, I had them retrieve diving rings from the pool. Another great project with this kind of fab shop setup is water rockets and launchers. So here, students can learn more about aerodynamics and pressure, as well as some typical industrial components when it comes to how valves are connected, how pipe fittings are connected, things like that. And building a launcher will use most of those tools. Besides water rockets and launchers, there's simple robot frames, as well as any other basic electromechanical system. So in the case of a fab shop, you're going to have a project that is either more mechanically robust, like a larger catapult, or if it does have an electric component, it will be much simpler than anything programming or a digital circuit. It'll have an on-off switch, or they'll be using lights or things like that. So an example might be a t-shirt cannon, where they have one electric valve open and close the air, or things like that. So directly opposed to that, our next medium budget project or medium budget set of materials is microcontrollers and robotics. So this is each student group will need a microcontroller, so an Arduino or something similar. I suggest starting with Arduino. There's plenty of documentation on it. They'll need a motor controller. So these are inexpensive ways that microcontrollers like Arduinos can power motors. You'll want to have breadboards and jumpers like before, the combination wire cutter, wire stripping tool, and then some sort of power source. And in this case, we'll probably want to start looking at a mobile power source. So something along the lines of a AA battery pack and rechargeable batteries, or a rechargeable nickel metal hydride battery. And then shared for the whole classroom, you'll want a few soldering stations so they can customize any sensors and attach wires if necessary, as well as add connectors. You'll want to have some assorted component kits from before, like resistors, capacitors, LEDs, as well as some sensor kits. So they make common sensor breakout boards, what they call them for Arduinos, where it's something like an environmental sensor with the required circuitry to make it work in an easy to use package that plugs right into the Arduino or right into a breadboard. So something like a light sensor or a vibration sensor or a touch sensor to start adding control loops to the robot. So that's where it will react to a stimulus. You'll want a selection of motors and servos. And you'll also want to make sure that you get DC gear motors. So those toy motors where there's not a gearbox attached will usually spin too fast without enough torque to actually drive a robot. So these common yellow motors, they're called TT motors. They're inexpensive and they're a great kind of power to weight ratio for hobby classroom robotics. You'll want a couple of precision screwdriver sets because there's going to be a lot more connectors with small screws and terminals, things like that. You'll want a couple digital multimeters for your students to troubleshoot with, hot glue gun and glue, and then again, small part storage. And this is another good option where you can incrementally invest to make this kind of match your budget a little better. And it's a very versatile option where students can go from building little cars. So in the top corner, those are obstacle avoiding robots. And we're cheating a little bit where those actually have some 3D printed frames, but you very easily could do that with recycled or reused materials. I've built a very similar one for my first ever line following robot using a sandwich container and M&M mini soup, based on the excellent Robot Building for Beginners book by David Cook. So all of these are examples of differential drive robots. So these fit really well in a classroom where rather than having a steering wheel or something turn wheels to steer it, you have two motors that are fixed and you change the speed and the direction of the motor to steer it. It takes a lot of the complicated mechanical design aspects out of these projects and will just make it a much more approachable project for your students. So in this case, you have a line following option where you have a black line on white paper and the robot will drive along it. You can have obstacle avoiding where, like these little robots, they have a tiny sonar sensor in the front that only costs a couple of dollars. So if it sees something, your students can either program it to back up and turn or scan and survey the area, things like that. Light seeking is also a very popular one where you can have robots be little light spiders with two photosensitive eyes. So they'll chase a flashlight around or they'll run away from a flashlight. Taking this the next step, you can take your robots to the high seas or at least to a local pond. So unmanned surface vehicles are kind of the next step where you can see where you need a bit more tools that we talked about in the fab shop to make that work. But it's an option for your students to get much more real world test. And it's a unique experience that they usually don't get a chance to, where they're familiar with seeing a lot of tracked robots or ground robots or drones, but on the water is kind of an unusual one, but I could be biased with my background. And another great series of projects with these are soft circuits or wearable electronics. So in this case, those two stuffed animals, well, they look just like stuffed animals. Those actually have voice boxes in them that the students wired up and programmed with sensors, so they'll say things when you walk by. They also design the whole pattern. A final option with microcontrollers and robotics is looking at IoT projects or Internet of Things projects. So remote sensing or automation, this could be something where you had a light turn on when someone walked into the classroom, or a simple security alarm, or remote sensing if you have like a classroom aquarium. Your students can program some sensors and it will log the temperature and the salinity and things like that and help monitor the aquarium. So now we're getting into the expensive stuff. So additive manufacturing, or the rather ubiquitous 3D printer, I feel it's the most commonly talked about and most commonly misused tech tool. So a 3D printer works by melting plastic layer by layer to make an object based on a model. There's tons of benefits where it can give your students a chance to iterate quickly through a design and easily change things. So if they want to tweak the thickness or do a more precise design, it takes a lot of the building skill out of the engineering process, which they might not have at their age. However, it's really easy for the 3D printer to no longer be a tool and just become a toy factory where they're downloading models and just printing action figures, things like that. Another thing to think about with 3D printers is they're very, very slow. So you're going to have to plan that into your lessons where if they start something printing, it might not be done for hours and hours on end. It's also critical to have training in your specific 3D printer. They're all a little different. They all have various personalities. They'll all clog up and require troubleshooting and things like that. So it's not great as a standalone option if someone's not going to be invested in upkeeping the machine and learning how to use it and learning the ins and outs and quirks of your particular printer. So some examples of 3D printer projects. We have kind of the engineering ones where we're looking at rapid prototyping and precise designs, as well as mass production. So both of those upper robots were 3D printed frames filled with electronics. One had a very artistic scene, as you can tell. Looking at the science side of things, it's a really good way to do hands-on models. So a representative model of cells, things like that, DNA, different chemicals, things you can otherwise see. And a great part about them is there's tons of open source and documented projects on websites like Thingiverse, My Mini Factory, Instructable, and Scan the World, where you can find models or curriculum ready to go if you're not quite ready to dive into 3D design. Then our final expensive option is any of the digital fabrication. So it would probably be one of these. You have a laser cutter, a CNC router mill, or a vinyl craft cutter. So a laser cutter uses a laser to cut sheet goods. There can be exhaust concerns, fumes. They're usually really expensive, but they can be great for prototyping. A CNC router or mill is subtractive manufacturing, so it uses a cutting bit to remove material. They can be very dusty and very noisy. And then a vinyl craft cutter is basically a computer-controlled X-Acto blade, which limits you to vinyl, paper, cardstock, or similar. These will all require quite a bit more training because the machines are specific to each manufacturer, and there can be some fairly significant safety or environmental health concerns that you have to mitigate, such as exhaust or things like that. So some sample projects with a laser cutter, you're going to be looking at desktop models. You can do much more complex mechanisms like robot arms, but they're not the most robust based on the materials a laser can cut. And one neat thing to think about with a laser cutter is T-nut construction or other box joints, where it's ways of taking 2D sheet goods that you've cut and making a 3D object. So that's where you've cut tab and slots on the corners, or you've cut various slots that can hold a nut and a screw to hold it together. For a CNC router or mill, you'll have larger, more complex projects. You can get into cutting some non-ferrous metals like brass or aluminum. So it makes it great for FIRST robotics, or especially FTC and FRC. It also pairs really well with extrusion systems like 80/20 or MakerBeam. So these are basically an engineer's erector set where students can design and cut custom joining plates and then use the extrusions to connect them together. You also can use a CNC router to make custom printed circuit boards using tiny end mills to get your circuits to the more advanced level. When they breadboarded a circuit and finalize their design, they can make it for mass production with the CNC router. For a vinyl or craft cutter, you're going to be limited to stencil mask or pattern template making, as well as any aesthetics where it's cutting out paint stencils or things like that to kind of add some style to their project. So it's not necessarily the one we'd recommend starting with, but it's a good addendum. Some of the projects I've done with a vinyl or craft cutter is having students design stencils and then using acid to etch glasses or things like that, or to cut heat transfer vinyl to make custom shirts for the robotics team. One final sample use that we have for all these digital fabrication tools is if your students run a student store, it's a good opportunity where they can sell creations that they've designed for their various teams or other club fundraisers, things like that. So when it comes to planning for the future, you should think about the cost of consumables, as some of these will require much more expensive materials than others. And also you want to make sure that you're not shooting yourself in the foot by spending too little at the start and then having tools wear out. So it could be more beneficial to invest a bit more for the longevity of the tools. However, across the board, I think in any case, the best investment for any maker classroom is an instructor that's knowledgeable and passionate about what they're doing. There's plenty of classrooms that have the most expensive tools in the world, and they just sit there because they were bought without really having someone who is dedicated and passionate about making them. So hopefully this has given you plenty of tips on what to do. Happy making. Thanks for joining my session. You'll automatically be awarded points for attending. At the end of the conference, you'll receive a digital certificate noting how many sessions you attended, and I hope to see you during our live Q&A right after this.